Okay, so today we're going to look at section 2.3, functions and relations. So we'll start with the definition. A set of ordered pairs, x, y, is called a relation in x and y. So first thing to note, a set of x values is called the domain, and a set of y values is called the range. So it's easy to confuse these, so I just think of it as alphabetical. X comes before Y in the alphabet. Domain comes before range in the alphabet. That's the best way I've come to keep track of which is which. Okay, so we can look at a function here, or not a function, a relation here. We might have, we'll have X and Y values. We have 3. X is 3. Y is -4. X is -2. Y is 0. X is 5. Y is 3. X is 1. Y is 0. This would be what we're looking at, and what we want to do is write the set of ordered pairs that defines this relation. So simply rewrite it as 3, -4, -2, 0, 5, 3, and 1, 0. Then it asks, what is the domain? Well, the domain is simply the set of all the x values in this case. 3, -2, 5, and 1. And the range is -4, 0, 3, and 0 again, so we only list it once. Okay? So that brings us to the thing that we're really going to be dealing with in this class. Talk about a function. Given a relation, in x and y, we say that y is a function of x if for each value of x in the domain, there is exactly one value of y in the range. So let's look at some examples here. Let's see. We'll look at this set of points, 8, 4, 3, -1, 5, 4. Is this a function? Okay, so every value of x, there is only one value of y. So Fortunately, I have three different values of x. So in this case, this is a function. For the x value of 8, the y value is 4. That's the only y value for 8. For the x value of 3, the y value is -1. That's the only value of y for 3. And same here. Now note we do have 2y being the same on 2, but it's if one x has two different y's, that is not a function. So let's look at another one. Let's look at -3, 2, 9, 5, 1, 0, and -3, 1. Okay, so -3, I have a value of 2. That's okay so far. 9, I have a value of 5. Okay. 1, I have a value of 0. Here I have -3 and a value of 1. So this is not a function. Because for the value of -3, I have two different values of y. That means it's not a function. So, of course, we're not going to be dealing with points in here. We're going to be dealing with graphs of equations. That makes it a little more difficult to tell if something is a function, but there is a method. It's called the vertical line test. Now, I'm not going to write this down. We're going to do an example of it instead. So this is what the vertical line test says. Consider a relation defined by a set of points x, y, graphed on a rectangular coordinate system. The graph defines y as a function of x if no vertical line intersects the graph in more than one place. So let's look at some examples here. So what if I have something like this? Well, I do my vertical line test, draw a vertical line. Can I draw a vertical line that passes through more than one place? I can, so not a function. Okay, let's look at another one. How about this here? Can I draw a vertical line? No, I can't. So this is a function. Now, what about this one? And I'm going to label this point -1, 3. And then I'm going to label this point -1, -2. Is that a function? Well, look, for x here and x here, they're the same. They have different y's, so no. However, if I were to change this to an open circle, which implies that that point is actually not part of the graph, then it would be. So we have to keep that in mind when we're looking at piecemeal. Okay, so let's move on. How about function notation? I'm sure you've seen this. Something along the lines of f of x equals x minus 2. So what does this mean? F of x is a replacement for y. We're implying that this is going to be a function. Now the notation we'll look at is we might have something like this. Find f of 3 and f of 1 and f of 0. And all this means, and we could do -2, f of -2. All this means is take this and replace x with this. I have 3 minus 2, which is 1. Here I have 1 minus 2, which is -1. Here I have 0 minus 2, which is -2. And here I have -2 minus 2, which is -4. So I would have the corresponding points, 3, 1. -1, or 1, -1. 0, and -2, and -2, -4. That would be the points represented by this. I could graph these points and draw the line that passes through them. Okay, so let's look at something a little more complex than that. How about f of x equals -x squared plus 4x? And we'll start out with an easy one. Let's just do f of 2. So this means replace every x with 2. So this becomes -2 squared plus 4 times 2, which is a negative of 4 plus 8, which would be 4. Okay, what about something like this? F of t. All this means is replace x with t. So I get negative t squared plus 4t. How about this one though? F of a plus h. Well, again, it would be the negative of a plus h squared plus 4 times a plus h. Okay, so we want to look at this. The negative of a squared plus 2ah plus h squared plus 4a plus 4h. And we could distribute this negative if we wanted to. Negative a squared minus 2ah minus 4h squared plus 4a plus 4h. And there we are. Okay, so intercepts using function notation. Given a function to find y equals f of x, the x-intercept or intercepts are the real solutions to the equation f of x equals 0. Remember we said earlier that to find the x-intercepts we set y equals 0? Well, f of x is our replacement for y. And then the y-intercepts is given by f of 0. So let's look at an example here. I have f of x equals the absolute value of x minus 5. And I want to find the x and y intercepts. X-intercepts, y-intercepts. So to find the x-intercepts, I set f of x equals 0. So 0 equals the absolute value of x minus 5. Add 5 to both sides to get 5 equals absolute value of x. So x is equal to 5 or x is equal to negative 5. So these would be negative 5, 0, 5, 0. For the y-intercept, we simply set x, we find f of 0, which is equal to absolute value of 0 minus 5. absolute value of 0 is simply 0. So this becomes -5. And our y-intercept is 0, -5. So let's just look at a graph here. Okay. This point here is 4, -2. This point here is 2, -4. What is the domain? And what is the range? And we'll use interval notation for this. Okay, so the domain is all the x values. Remember, this is 4. So what is my minimum x value? Well, it keeps going to the left and this goes on and on forever. So my minimum x value is -infinity. And of course, it's never included, so we use a parentheses. My highest x value is 4, and it has a solid dot there, so it is included. So that's my domain from -infinity to 4. Now let's look at my range here. What's my lowest y value? It's this -4 right here. And it is included. And what's my highest y value? Well, it goes on and on and on up to infinity. And of course, infinity is never included, so we use a parentheses. So that's all well and good when we have a graph, and we could graph some of these things. But to determine the implied domain of a function defined by y equals f of x. There's two things we need to take into account. First, exclude values of x, because we're talking about domain only here, that make the denominator of a fraction 0. And remember, we cannot divide by 0. Second thing to consider is exclude values of x that make the radicand negative within an even indexed root. So remember, I told you we wouldn't be dealing with any more imaginary numbers since we're using a rectangular coordinate plane. If we get something with a negative under a radical, that's an even radical, so a square root or a fourth root or a sixth root, we cannot do that anymore. It doesn't work. That's how we can restrict the domain of our functions. Okay, so let's see. We want to write the domain. So my first one is f of x equals x minus 2 over 3x plus 1. So we don't have a radicand to worry about, but we have a fraction. So to find the value that is not able to be in our domain, we set the numerator or the denominator equal to 0, solve for x. So this means that x cannot be negative 1/3. So x can be negative infinity all the way to negative 1/3, not including it, union with, again, not including negative 1/3 all the way to infinity. In other words, everything but negative 1/3. So let's look at another one. So we'll say g of x equals x squared over 5. Are there any limitations? We don't have a radicand or a radical. We don't have an exponent in the denominator. So in this case, it's simply all reals. Okay, let's look at another one here. How about k of x equals the square root of x plus 3. Okay, square root, that means the 1/2 root, square root, it's an even, so we can't have a negative under the radical. So this means that x plus 3 must be greater than or it can be equal to 0. So here we just simply subtract 3, and that's how we can restrict the domain so that this can be still be a function. So my lowest number, since x is greater than or equal to negative 3, is negative 3, and it's equal, so we include it, and it goes all the way to infinity. Okay, last one. We have p of x equals 2x squared plus 3x. Again here, we have no fractions with a denominator, with a variable in the denominator. We have no radicals or radicands. So we're good here. This can be any real. Okay, now let's see if I can draw this picture. I have a point here of negative 1, 1. And this does go through the origin. And this point here is negative 3, 1. So first thing I want to do is find f of negative 2. So that means when x is negative 2, what is y? Well, that would be right here. So that's 1. Next step, f of 4. Nope, it stopped down here, didn't it? F of 4. At f of 4, this is an open circle. That means it's not included, so does not exist. Okay, C all x where f of x equals 3. Okay, f of x equals 3. There's only one right here, and that is 3, 3. Wait, 3, sorry. F of x equals 3, so that means y is 3. And that is -4. Oops. -4, 3 would be that point. So if f of x is 3, then this is so where y is 3, x is -4. Okay. All x where f of x equals 1. Okay, that's here to here, all of these. That's an interval. Includes -3 to -1, which it also includes. E, x-intercept. That is the origin here, 0, 0. And f, well, y-intercept is also the origin, 0, 0. And then we want the domain of f. So the domain is the x values. So this goes on and on and on to negative infinity. All the way almost to 4. So we put 4 and show that 4 is not included. And then for the range, well, my lowest point is here at -4, but it's not included. And this goes on and on up to the infinity. Okay, so that finishes up 2.3. Have a good day.